for problem 3, this is your normal truss analysis. You're working with this section of the truss. You can ignore what happens on the right side. But the interesting thing about this truss is you have this distributed load on the truss. What you need to do is turn this distributed load into point loads. What do I mean by that? I mean, if you look at, you have something that looks like this. And it goes on for more floors, but you have a distributed load. It goes like this. And you want to turn that into point loads here at the floor level. We do that by splitting the distributed load, by distributing this distributed load. We use tributary widths, tributary areas. So you can imagine that this half distributed load goes to the top level. This goes to the second from the top level. This goes from the third to the top level. So P roof is going to be equal to 3.6 divided 3.7 divided by 2. It gets half from the floor below, plus 0 divided by 2. There's no floor above us, times W. This is 2, 3, 4, 5. This is P5. I'm not sure what floor that is, but the second floor from the top actually. P5 is going to get 3.7 divided by 2 plus 4.6 divided by 2 times W. And for just to further illustrate the point, P4 is going to be 4.6 divided by 2 plus 4.6 divided by 2 times W. Those will be your forces. Once you have all these forces on your truss, you can do your normal truss analysis using method of sections or method of joints. Now there is a question about what happens when you get to the very bottom. Because now you have 2 pins here. It looks something like this if I just draw the section here. These 2 pins are not allowed to move. Because these 2 pins are not allowed to move, this cannot deform. No deformation. Your stress is equal to, you have a stress-strain relation, strain relationship. If there's no strain, if there's no deformation, there's no stress. Actually, I can't remember if this is correct. I can't remember if it should be here or on this side. I can't remember which side's which, but the important thing is that if there's no strain, there's no stress. If there's no stress, then there's no axial load. So equals this strain equals 0, sigma equals 0, therefore P equals 0. So this is a zero force member at the bottom because it cannot deform. So you can get rid of this one. And then if you get rid of this one, I believe you have your normal thing. You'll get, this is going to be equal to 0. You'll get a force here, and a force here. And you can solve your reactions. And let us know if you have any other questions on that one.